Welcome to the module Introduction to Collision Theory. Until now, we have mostly approached chemical kinetics with a macroscopic perspective by addressing the following questions. How do the concentrations of reactants change over time? And how are these changes related to the stoichiometric equations? In the case of elementary reactions, we saw that the reaction order can be derived from the stoichiometric coefficients. This allowed us to derive rate laws using simple integration techniques. We were also able to combine elementary reactions to construct reaction mechanisms and derive the rate laws of complex reactions. However, a major objective in chemical kinetics, which is a part of a broader discipline, physical chemistry, is to understand reaction mechanisms at the molecular level. The macroscopic perspective employed so far does not yet provide us with a microscopic understanding of how reactions actually occur. To address this, we now begin to explore how reaction rates can be explained on the basis of molecular reaction mechanisms. We focus on reactions in the gas phase and aim to develop a more detailed microscopic picture of chemical reactivity. One of the earliest and still very insightful approaches to this problem is collision theory. According to collision theory, a bimolecular gas phase reaction takes place when two reactant particles collide. The term particles in this context simply refers to molecules or atoms in the gas phase. We will employ the kinetic theory of gases to describe the motion and energy distribution of particles. Once we understand how these particles move, we can examine what happens when they collide and under what conditions can collisions lead to chemical reactions.